So the rest of the tetrapods, excluding the amphibians, are what we call amniotes because they're going to have the structure here of the amniotic egg. And there's two big sister groups here. There's the synapsids, which have one hole in the skull, where the bones from the jaw come up here to attach to the skull. And this is going to include the mammals, so this is you. The other group here is the diapsids, so di means two. And these have two holes in the skull, so that's the characteristic that's going to separate these groups out. And this is going to include all of the reptiles. And inside of reptiles, we have a couple of groups. We have the lepidosaurs, which are the snakes and lizards, and a lizard-like creature that is not quite a lizard called a tuatara, which only exists in New Zealand. There are several extinct reptiles that date back to dinosaurs. So we have some aquatic dinosaurs like the ichthyosaurs, plesiosaurus. And then all of these would be considered the dinosaurs. So pterosaurs, there's two groups of dinosaurs, ornithischian and saurischian. And then we do include birds in the saurischian dinosaurs. Closely related to the dinosaurs and birds, the most closely related is the crocodilians. And then, surprisingly, the turtles. We actually used to think that turtles were a completely separate group of reptiles called the anapsids because they don't have a hole in their skull. However, ancestral evidence has shown that turtles actually used to have ancestors that had two holes in the skull, and they have subsequently lost those. And so turtles having no holes in their skull would be a derived trait that would have showed up here. So what is an amniote? An amniote is defined by having an amniotic egg. And the amnion is a membrane. So here we can see the embryo, and it's surrounded by this amniotic cavity. And you've probably heard these words in relation to humans. So we have the amniotic fluid, which is the fluid inside of the amnion. And so when a woman goes into labor and her water breaks, that is a rupturing of these membranes, and the amniotic fluid is the quote-unquote water. So humans have an amniotic egg, we just no longer have a shell. So the shell here is going to help to prevent drying out. So this is going to keep the embryo that's inside of the shell inside of its own little private aquatic environment. So this is still an aquatic environment, it's just retained inside of a shell. We're also going to see that amniotes are going to have tougher skin. So we see keratin in the skin, which is going to help prevent water loss. So the big advantage of the amniotic egg is that now we are not tied to water for reproduction. We can go on land, places like deserts, and lay eggs in nests and not have to rely on being near a water source. So we're going to go ahead and look here at reptiles. So this is going to include tuatara, lizards, snakes, turtles, crocodilians, birds, and dinosaurs. And the key characteristic of reptiles is that they are diapsids, so that they have two openings in the skull. And those are openings that allow muscles that attach to the top of the head to reach all the way down to the jaw to allow them to close and not open, but close their jaw. There's two main groups. So we have the lepidosaurs, which is going to be tuatara, snakes, and lizards. And then the archosaurs, which is the turtles, crocodilians, pterosaurs, and dinosaurs, which would include birds. So this would be a big mosasaurus, which is extinct lineage of reptile that we believe was more closely related to lizards and snakes. There are two different types of dinosaurs, so two different groups. And the ornithischian, so this orno means bird, and ischium is talking about the hip. So we're talking about the shape of the hip here. So the ornithischian dinosaurs have the name bird hip, but the birds belong to the saurischian group. So they're the bird hip dinosaurs, but that doesn't include the birds. And the other group we have are the Saurischian, and this means lizard hip. And it's just, what it's doing is it's comparing the structure of the hip bones to existing species. So somehow these actually look more like birds do nowadays. The ornithischian dinosaurs tended to be more of the herbivores that walked on all fours, things like triceratops that had structures to help protect them against predators. And then the Saurischian dinosaurs tended to be the carnivores, the two-legged bipedal dinosaurs, so things like Velociraptor. This is an Allosaurus, Tyrannosaurus rex. And these would have been very quick and mostly meat-eating. So looking at our extant or living lizard or lineages is Lepidosaurus. This is a Tuatara. So it looks very much like a lizard. It is not technically a lizard. It does have a lot of difference in the cranial morphology as well as some other genetic differences that make it a completely different group. There's only 2 species and they live in New Zealand. Squamata includes the snakes and lizards. So all of these guys are lizards, including my chameleon over here. This is a glass lizard. So this is a legless lizard. The head shape is very lizard-like. It also is going to have eyelids. Snakes don't have eyelids. And so these are lizards that have lost their legs, and they are not snakes. And then this is the only snake on here. So even though it looks very much like a snake, it actually looks a little bit more like an earthworm. So there are legless lizards as well as snakes, and those are 2 different groups. The other main group of extant reptiles is the archosaurs. So this would include the extinct dinosaurs, but we don't typically include them because they're no longer alive. The most different is the turtles. So we think that turtles had an ancestor that did have those holes behind its skull, and then they subsequently lost those. And turtles, older turtles, so more ancestral turtles, were not able to pull their heads back into their shell. We do believe that the bottom of the shell developed first, and so there were likely ancestors to turtles that had a protection on the bottom but not the top, and then the top shell developed later. So this is called a side neck turtle, and so it's not able to retract its head fully, but what it does is it kind of lays its head to the side over here to help this little lip to protect itself. And then more modern day turtles are able to retract their head fully. These are much more terrestrial, so if you're seeing tortoises on land, these are going to be more like this, where they're able to pull their head and arms in fully. And then we've got sea turtles that are not able to retract their head. Their shells are relatively smaller, and then their fore and hind limbs have been modified into flippers. And so this is actually a modification of land turtles that went back into the ocean. Next on our tree, we have the crocodilians. So the crocodilians are going to be sister to the birds. And we have the American alligator, American crocodile. One way you can tell is this big tooth here. On the alligator, you can't see it. On the crocodile, this is going to stick out on the outside. You'll be able to see it. This is called a gharial. A gharial is a crocodilian that has a really, really skinny snout. And so these don't have quite as much biting force, but they still have some wicked sharp teeth there. There's only about 23 species of crocodilians in the western regions of the world, but birds would be considered Archosaurus close sister related to these crocodilians, and there's more than 10,000 species that have been adapted for flight. So we often teach that birds have like honeycomb bones. They're not quite honeycomb shaped, it's just that they're very hollow. And birds have a ton of adaptations to make them very light. So they have weight-saving adaptations. This means most birds don't have a urinary bladder. So when a bird goes to the bathroom on you, the white stuff that they secrete is actually solid form of urea. It's not poop, it's pee. And they don't have a bladder, so they don't have anywhere to store it, so it's not really their fault. They just have to go when they go. Most female birds only have one ovary instead of two. Birds are typically going to have small gonads and that swell when it's mating season and then they go away. They've lost a lot of structures. So they've lost teeth, claws, a lot of things that are heavy to make them very, very light, including bone density. And one of the distinguishing characteristics of birds is that they have feathers. And we do not believe that feathers evolved for flight. Because the earlier birds, like Archaeopteryx here, who was the first bird, this is right here, you could see that, they retain some of these heavy things. They have claws on their forearms, they have teeth, they have this really long tail that's got vertebra in it, so that's going to be heavy. There were feathers on dinosaurs before we saw any birds, and we believe that these evolved for temperature moderation, for insulation, for camouflaging, or for courtship, and then were adapted later into feathers for flight as we kind of traverse the development of birds. Birds are endothermic, which means that they are able to regulate their own internal body temperature. So that would make them one of the only reptiles that's able to moderate their own body temperature. Birds have color vision. They typically have excellent eyesight. Imagine being a hawk that's going to catch fish from really, really high up in the sky. So many birds have adapted to have very, very good vision. So living birds belong to a clade called Neo-Orthines. So this orthine means bird, and neo means new. So these are the new modern birds. And all birds pretty much have the same body structure. They have lost the forelimb claws. They mostly have hind claws. Most of them have some kind of beak for capturing prey or for feeding in some sort. Large wings, and then reduced structures elsewhere. The tails are typically only feathers. There's no more vertebrae or large heavy structures in the tails. There is a group of birds called the ratties, and that's going to include the emus, ostrich, and the kiwi. And these are the flightless birds. And they have a slightly different structure in the sternum here. So this is very flat, whereas the flighted birds typically have a very round sternum here. And that's because the sternum bone right here is very large to allow for lots of muscles to attach to it to power those wings. So this is where the sternum is. It's going to look kind of like a keel, and then the muscles from the wings attach down to that sternum. Even the penguins do have a big carinated sternum because they are able to fly, but they do so underwater. So penguins are not going to actually fly in the sky.